Module 2 will discuss Chapter 3 of the Pavement Type Selection Manual. This module covers AASHTO Pavement Type Selection Guidelines to prepare a pavement type selection report. Chapter 3 of the Pavement Type Selection Manual was printed with the permission of the American Association of the State Highway Transportation Officials, AASHTO. For the selection of the pavement type, there is no exact science. The highway engineer or administrator does not have at their disposal an absolute or undisputable method for determining the type of pavement which should be selected for a given set of conditions. However, the selection of the pavement type should be an integral part of any pavement management program. The highway engineer or administrator must make an engineering judgment on many varying factors such as traffic, soils, weather, materials, construction, maintenance, and the environment. The pavement type selection may be dictated by an overriding consideration of the structural design, cost analysis comparison, and for other factors. So let's take a look at a flow chart for pavement selection procedure. This flowchart incorporates the major and secondary factors to consider for the pavement type selection. It has 8 steps, and depending on how you answer yes or no, it takes you through the steps that you need to follow in order to complete the pavement selection process. Principal and secondary factors which may have some influence of the decision-making process. Principal factors: traffic, soils characteristics, weather, construction considerations, recycling, and cost comparison. This group includes those factors which may have major influence for structural requirements and they assign an economic value for comparative purposes. Now, the secondary factors include performance of similar pavements in the area, adjacent existing pavements, conservation of materials and energy, availability of local materials or contractor capabilities, traffic safety, incorporation of experimental pavements, stimulation of competition, and municipal preference, participating local government preference, and recognition of local industry. These secondary factors, which have a lesser influence, are usually taken into account when there are no overriding considerations or one type is not clearly superior from an economic standpoint. So let's start looking at the principal factors, beginning with traffic. We know that total volume affects the overall geometric requirements of the highway. The percentage of commercial trucks and that frequency of the heavy loads is the factor that has the major effect on the structural design pavement. Obtained from the Traffic Planning Office, the traffic data needed for the design life mentioned the opening year ADTs and the design years ADTs. The data should also include easel information for flexible and rigid pavements. Percentage of trucks is also an information that is valuable. Any percentage over 10% is considered a high percentage of truck volumes. This is an example on how the traffic information can be presented in the report. The key is the truck percentage and the heavy easels to determine what type of pavement is more suitable for the design. Soils is another principal factor that is very important in the load carrying capabilities and overall pavement performance. The roadway soil survey is vital in determining if native soils would favor one pavement choice over the other. Also, include in the pavement type selection report the lab resilient modulus memo and any design high water information that would be important to consider for the design of the pavement. Weather affects the subgrade and pavement wearing course. The amount of rainfall, freezing, thawing, and winter clearing operations affect the pavement wearing surface. For example, salt used to de-ice the roads causes corrosion to the rebar on concrete pavements. Also, asphalt becomes more brittle with freeze and thaw cycles, causing more cracks, potholes, and depressions. These weather factors such as rain, snow, frost affect the performance and the maintenance costs associated with them. The frost penetration will seasonally affect the bearing capacity of the subgrade material. Here in Florida, we do not see major temperature changes. However, extreme hot temperatures can also affect the pavement placement. Florida specifications for concrete requires protection from certain weather conditions under specifications 350-6, 346, and 400. Similar requirements exist for asphalt pavement, and these are covered under specs 330-3.1 and 330-3.2 that describe weather limitations for paving operations. And Table 330-1 covers the temperature requirements depending on the mixes. Here's an example of a pavement type selection report write-up for this principal factor. Stage construction is a construction consideration that may dictate the type of pavement to be selected. Some consideration could be the speed of construction, accommodating traffic during construction, the ease of replacement, anticipated future widening, seasons of the year when construction must be accomplished. Sometimes on urban interstate projects where maintenance of traffic is more difficult, the use of concrete pavement might be a good selection due to the minimal maintenance required. Here's an example of the construction phasing write-up and how each type of pavement compares with regards to the placement and MOT. The opportunity to recycle material from an existing pavement structure or other sources may dictate the use of one pavement type over the other. Also, future recycling opportunities may also be considered in the selection process. Both pavements have been good candidates for recycling. Here's an example for a pavement write-up for the pavement type selection report. Last principal factor is cost comparison, where there are no overriding factors and several alternate pavement types would serve satisfactorily. Cost comparison can be used to assist in determining pavement type. FDOT Pavement Management section has developed an Excel form using the principles for life cycle cost analysis covered on the FHWA site already mentioned in Module 1. This Excel sheet will be used to perform the economic analysis and also prepare that cost comparison. This looks at the initial construction cost and the cost of maintenance or repair cycle. We will cover the guidelines for estimating initial and future strategies and this Excel form in more detail in Module 3. Costs to road users during periods of reconstruction or maintenance operation are also appropriate to consider along the initial cost. Here's an example of the summary of the cost comparison to be included in the pavement type selection report. A secondary factor to consider in the analysis is the past performance of similar type of pavements in the area. This is a valuable guide provided the conditions are the same. Caution must be urged against reliance on short-term performance records or on those on long-term records for which the pavements might have been subjected to much lighter loading for a large portion of their present life. Another secondary factor is adjacent existing pavements, provided there are no changes in the conditions. Existing pavements in the area have provided adequate service. The continuity will also simplify the maintenance. Here are included two examples of the narrative used on the pavement type selection report for these two secondary factors. Another secondary factor to consider in the conservation of materials and energy, the pavement type selection could be influenced by a pavement that contains less of a scarce critical material or the type whose material production, transportation, and placement requires less energy consumption. The availability and adaptability of local materials may also influence the selection of pavement type. The availability of commercially produced mixes and the equipment capabilities of area contractors may influence the selection of pavement type, particularly for small projects. Shown here are some example write-ups for a pavement type selection report. Traffic safety is also a consideration. The characteristics of wearing surfaces, the need for delineation through pavement and shoulder contrast, reflectivity under highway lighting, and the maintenance of a non-skid surface as affected by the availability of materials in specific locations. The incorporation of experimental pavements in some instances is needed to determine the performance of materials or design concepts by field testing under actual construction, environmental, or traffic conditions. In those instances, Pavement Management Office and State Materials Office would most likely make their recommendation and oversee the process. Included in the slide are examples of write-ups for the pavement type selection report with regards to these subjects. It is always desirable to avoid situations that promote monopoly or ignore the healthy competition among industries with regards to pavement materials. Where alternative pavement designs have comparable initial and comparable costs with service life, the highway agency may elect to take alternative bids to stimulate competition and obtain lower prices. It is important to maintain good engineering practices and product improvement for making costs more competitive. Where several materials will adequately serve as a component within the pavement structure, such as sub-base or base course, contractors should be given the option to use any approved material. Municipal preference or participating local government preference sometimes need to be considered, especially if other factors are indecisive as to the pavement type. Included here are examples of write-ups for a pavement type selection report on these two conditions. In the pavement type selection report, always include a brief summary of the information. A table similar to the one shown on this slide can help summarize if one pavement is favored for the principal or secondary factors over the other. Once that is shown, then a conclusion can be reached of which pavement type is best suited and recommended for the design. This concludes Module 2, AASHTO Pavement Type Guidelines. You're now ready to proceed to Module 3, Pavement Selection Process Guidance.